Hey guys, welcome back. We are in our second to last week here, which is crazy how fast it's going by. We are continuing our work with rational expressions this week. Just to kind of jog your memory and remind you where we were at. Last week we worked just on simplifying rational expressions. So we went through a bunch of factoring review. And then we also learned how to multiply and divide rational expressions. When I say rational expressions, I'm talking about stuff like this. Like I asked you to multiply things like this. And we would factor things and cross things off and just write our answer as like some fraction, and then we would say things like, but x can't equal 4 or stuff like that. So that's what we did last week. This week we're working with the same type of stuff, but this time we're going to talk about how do we add rational expressions and subtract rational expressions, because we haven't talked about that yet. So before we jump into that, let me just remind you how we add regular fractions. Remember that, actually before I say that, here's a misconception. Some people would say that the answer to this problem here is 6 over 12 because they would just go straight through and say 2 plus 4 is 6 and 9 plus 3 is 12. That is, okay, so 6 over 12 is the same thing as 1/2. That is very, very wrong. If you think about 2/3 just by itself, that already is bigger than 1/2. So how can you add something to it and then get something smaller to be that than what we started with? Like, that would make no sense. So that's very, very wrong to do it that way. Remember, when we add fractions, we have to get common denominators. So when I look at 9 and 3, I think, okay, the easiest way is maybe to make both of these denominators 27. And how did I get 27 by 3? Well, I times it by 9. So I'm going to do the same thing to the top. I'm going to times that 2 by 9 and I get 18. And then same thing for this one. How did I turn this 9 into 27? I had to times it by 3. So I'm going to times the top by 3 and I get 12. Then when we add that together, the bottom is still 27. And the top, when you add this part together, you get 30. And so that's our final answer, but of course we could always look to see if we can reduce. I'm noticing right away that 30, you can divide that by 3, and you can divide 27 by 3, and that would leave you with 10 over 9. And I can't divide any. That would be my final answer, is 10 over 9. Okay, let's practice the exact same thing this time with part B. So when I look at my denominators, I have 7 and 3. I think the easiest way would just be multiply those together, 7 and 3, get 21, and then say, okay, how did I get from 7 to 21? I times by 3. How did I get from 3 to 21? I times by 7. So I'm going to times this one by 7 and this one by 3. 4 times 3 is 12, and 1 times 7 is 7. Adding that up together, I would get 19 over 21, which cannot be reduced, so I leave it like that. Okay, so that's how we add fractions when you don't have common denominators. Step 1 is to get common denominators. And the easiest shortcut for common denominators is I can just multiply by the other number, right? So in this case, with this number, I just multiplied by 3, and with this one, I just multiplied by 7. So when I look back at part A, I could have had both of these denominators be 9, but I didn't even want to think through factors. I just thought, why don't we just multiply those by each other and do 27 instead? That way I just don't really have to think. So you'll never really have to think through factors if you just do that trick. Multiply them by each other and use that number. And that's the exact same thing that we're going to do with rational expressions. When I need to get common denominators, that'll be a cool trick that we can do, is just multiply the denominators by each other, and I don't ever have to think through anything else. This page is just here to remind you that if they already have common denominators, then all you have to do is add the top and you're good to go. Same thing with subtracting. If they already have common denominators, that number stays and all you have to do is subtract. If they don't already have common denominators, you have to make sure that you get them. Okay, so here's a couple of quick examples. Are these common denominators? Yes. So my denominator is going to stay as 4x, and the numerator would be 7 plus 3 is 10. And that's my final answer. Now I will look to see if I can divide these and simplify it down just like we did with regular numbers. And if you look, 10 can be divided by 2, and also 4x can be divided by 2. So I really would rather write that as 5 over 2x and leave that as my final answer since that's the most reduced form. So this is just an easy example where I already had common denominators, little work is involved. Now I want to do a little side step here for a second and just explain why would you not add those together? Because I could see some people saying, oh, the denominator is going to be 8x or something like that and add the denominators. And let me show you why. If we go back to elementary when we learn fractions, let's say you have a piece of pizza and you cut it in fours. And I want to add together 1/4 plus 2/4. So if I were to write that out, I'm doing 1/4 plus 2/4. Well, if you just look at the picture, if you put all that together, you can see that that's 3 out of 4. And so what did we do? We did not add together. We didn't say that's 3 out of 8 because you still have 4 pieces. It's 3 out of 4 because you filled up 3 of the 4 pieces. So the denominator, the bottom number, is never getting added together because you're still talking about that you're out of that many pieces of pizza or pieces of pie or whatever. So same thing when we do expressions like this. You're not adding together the denominator. The denominator is still going to stay the exact same just as it would over here when we do regular numbers. Okay. I want you guys to pause and do this one down here and notice the denominators are the same, so it's going to be a pretty quick problem. All right, so checking this answer, since the denominator is the same, I don't have to do any work there, and I will add the top. 2 plus 1 is not 1. 2 plus 1 is 3. And I can reduce this. You can divide those 3's out and just write it as 1 over x squared and leave that as your final answer. Okay, so let's move on to what happens when you do not have common denominators. So think back to, let me go way back to these ones we did. When they didn't have common denominators, we just multiplied these numbers by each other. And that's the exact same thing that we're going to do here is if these numbers are not the same, then just multiply them by each other and then force them to be the same number. So kind of the same exact trick that we did with regular numbers. And this over here is just showing you that it's the same thing for subtraction. Okay, instead of continuing to go through this with letters, why don't we just jump straight into an example? So here's an example where I'm asking you to add these fractions, but they do not have the same denominator. So what I can do is I can just say, well, why don't I make the first denominator, it's already x plus 5, but why don't we multiply it by x minus 4? And then the second fraction already has a denominator of x minus 4, that's the one already there. Why don't I just multiply it by the other one, which was x plus 5? Okay, and actually, I'm going to switch my color coding to be the exact same. So I'm going to pause and do that, and you'll see it switch in a second. Okay, so here's what I did. Here's the original, and all I did is multiply in this extra x minus 4. Here's the original in the second one, which matches to this one, and all I did is multiply in this extra x plus 5. But if you look all together, in the yellow box is the exact same thing as this yellow box. So I have common denominators just by multiplying by whatever expression it didn't have. Okay, remember what I do to the bottom, I have to do to the top. So let's do the first one. The first one had a numerator of 3x, but I multiplied this additional x minus 4 in the bottom, so I need to multiply that additional x minus 4 in the top. And that's it. We'll simplify it in a second, but that's all the thinking we really have to do. And then for the second one, the numerator was 6, but in the denominator, it already had x minus 4, so it already had this one right here. I multiplied in this extra x plus 5, so I need to multiply by the top by the same thing, the extra x plus 5 that I added to the bottom. All right, and now let's simplify. So the bottom is just going to stay the same, just like it always is when we add fractions. If you have the common denominator, then your denominator is the same. And now we just have to figure out how to put together this whole numerator. So I'm going to start by distributing out everything I can distribute. So let's distribute that piece, and that would be, what, 3x squared minus 12x. And then I have this plus sign right here, so I'm going to say plus. And then let's distribute out this 6. So plus, that'll be 6x plus 30. And I can also combine these together. Let's see, that would be negative 12x plus 6x would be negative 6x. I'm just going to erase this instead of write a new line and just do negative 6x. And now this looks like a problem like we did last week, where I'm going to try and factor this numerator and see if I can get anything to cancel with the denominator. If you need to pause the screen here to look at anything I've done, I'm going to erase this top part and rewrite this at the top just so I have a bit more room. So pause it here if you need to look at anything, but I'm going to start the screen back up with this box in a second. Okay, so here we're at this stage. And now, again, just to remind you where we're at, we're going to factor the numerator and see if I can get any of these two things to cancel out just to see if I can simplify it further. So let's go through factoring. I'm noticing that this, and this, they all can be divided by 3. So I'm going to factor out a 3 in the numerator, and what would be left is x squared minus 2x plus 10. And again, my denominator stays the exact same. And that might make it a bit easier to factor this part. So think of factors of 10. So what are they? 1 times 10 and 2 times 5. And see if there's any that add to get you to negative 2. And there's not, right? 1 and 10 is never going to help us to get to negative 2. And neither is 2 and 5. So actually we cannot factor this any further, which means I'm just going to leave my final answer at that step where I had taken out the 3. I'm really just rewriting what I just had. I took out the 3 and I found that I couldn't factor any further. And so this is my answer. And since I didn't like cross any of these off, I don't need to say x can't be 4 or x can't be 5 or anything like that, because we only do that when we cross things off. It's obvious because I didn't cross anything out that x can't be negative 5 and x can't be 4, because that would make the denominator 0, but that's not a surprise because I canceled anything out earlier. That is already there. It's already stated. I didn't cross anything off, so I don't need to say that. So this is my final answer, and this is what the sum of those two rational expressions look like. Okay, so let's do another example, really similar. I just kind of want to show you shortcuts that you can take with what you write out. So notice we do not have common denominators. Let's force common denominators by multiplying this expression with this expression. So I can just already write that under one giant fraction if you don't want to write that out twice, and know in my head that this is how I made common denominators. And then I do have to counterbalance, because since I did that to each denominator, I have to make sure that I've done that to each numerator. So the first one, which just had a 7, we would have had to multiply by the 3x squared plus 3x, because originally the denominator was just 9x squared. So since I multiplied these together, over here on this side, I multiplied by 3x squared plus 3x, so I have to make sure I do that to the top. Okay, and then I'll write my plus sign. And then the one that just says x, since that had a denominator of this one already, I need to multiply it by this extra 9x squared. So that's just the little bit of a shortcut you can do instead of, well, I guess I erased it already off that page, but instead of writing them out twice and writing out your common denominators like this and then putting them together, you can just put them together straight away from the first step if you feel comfortable with that. Not a difficult thing to do, so I think we should be good to go at that. Okay, so the nice thing is from here I can already just start distributing things out and combining whatever like terms I can combine. So with the numerator I would get 21x squared plus 21x plus 9x cubed. And in the denominator, if I were to distribute this out, I would get 27x to the 4th plus 27x cubed. Lots that can be factored both on top and bottom. So let's look at the top. I'm seeing that in the top, in the numerator, 21, 21, and 9 can all be divided by 3. And I can also take out an x from all of these. So I'm going to take out a 3x. And what would be left is 7x plus 7 plus 3x squared. And then in the denominator, I have 27x to the 4th and 27x to the 3rd. So I can take out a 27x to the third, and what would be left is x plus 1. All right, and now let's just simplify this down a little bit. 3 over 27, I can reduce that fraction to 1/9. So I'm just going to erase it right there and write 1/9. Now, is it really necessary to have this 1 in the top? No, because timesing by 1 doesn't do anything. So you could just take that part out and have the denominator be over 9 instead of 27. Then the only other thing I can really see that you could cancel or simplify is this x over x cubed. This x can cancel out if you drop this one down to a square instead of a cubed. Just for time, or not time's sake, but for space, I'm just going to erase it like I'd been doing and just do it right here. And then the only other really thing I would do is write this in standard form, where you have the highest power in the front, just because we're used to seeing it like that. So I'm just going to move this 3x squared to the front end of things instead of in the back, because we're used to seeing quadratics with the highest power first. And I'm just going to pause and clean this up, but I'm not going to do any more math. So there's my final answer, and we're done. So the next example I want to show you guys is one where you have a little bit more complicated denominators. So notice I have 3 terms in this one, whereas this last example I had 1 term and then just 2 terms. So there wasn't quite as much to distribute. But you saw how when you distribute it out, it does get complicated. I mean, this was kind of complicated, like pretty fast. So you can imagine that if I were to have to multiply these denominators together and FOIL all this out, it would start to get really complicated on the bottom, and then I would struggle with how to factor once I have all those terms written out. So what you want to do when you see ones like this where you already have a trinomial is see if you can factor that right now before we multiply it together with anything else. So before I move forward, let's try and factor. So what are factors of 18 that can add to get me to 7? So writing out my factors of 18 would be 1 in 18, 2 times 9, and 6 times 3. And the ones that can add to get me to 7 would be 2 times 9, because I can do 9 minus 2. And it's okay that I make the 2 a negative, because I was actually multiplying together to be a negative 18, so that's perfect. So let's write the fractions just as they are, but instead of the first denominator as it is, I'm going to write that as x plus 9 parentheses x minus 2. Okay, so all I've really done is rewritten the problem but changed this to this. So now I can move forward with the rest of the problem. And I will need quite a bit of space here. So my recommendation when you write this out in your notebook is write everything out really thoroughly. Give yourself a lot of space. Double check everything before you do a new line to avoid having to go back and fix mistakes. So definitely write this one down in your notebook as you follow along, because I'll be stopping and erasing previous steps to give myself more space to write. All right, so I need to have common denominators, so I'm going to multiply all the denominators together, and I'm going to do this at the top of the screen. So I would get, let's see, my first one is x plus 9 times x minus 2. And then the second fraction is just an extra x plus 9. So I'll write that one out twice. And then for my numerators, so the first one I had 14. The denominator that went with that one was this one, so I need to multiply it by this one, the x plus 9. And then I have my plus 6. The denominator of this fraction was the x plus 9, so I need to multiply it by the other one, which is the one that had x plus 9 and x minus 2. Again, just to recap why I'm doing that, you have to multiply the numerator by whatever you multiplied the denominator by. So if I just look at this fraction, the denominator had these two. So how did I randomly get this extra one? Well, it's okay because I multiplied it in the top as well. And then same thing, over here in this green box, the denominator was just x plus 9. So how did I all of a sudden get these extras? Well, it's because I also added it into the top. So that's why you have to do that. Okay. So let's move forward with this problem. From here, if you can notice anything you can cancel, it will make your life a lot easier to cancel it now. But you can't get all cancel happy, and you can't do something like, let me show you something that would be wrong that I could see a lot of people doing. people might say, oh, this x minus 2 and this x minus 2 cancel. However, that's incorrect because there is no x minus 2 over here to cancel. You have to have the same term in all three things in order for it to cancel. So that will not work. But what will work is there is an x plus 9 here, here, and here. And so I can cancel that since I do have it in all three things. So now let me write what I would have left. I have 14 plus 6 times x minus 2 over x plus 9, comma, or parentheses, x minus 2. And now let's go ahead and distribute and see what else I can simplify. Again, I can't cancel these x minus 2's because there is no x minus 2 in this term. You can only cancel if it's in every term. So foiling that 6 out, or distributing that 6 out, you would get 6x minus 12. And the denominator I'm not going to FOIL out because I'm hoping that something will cancel with these. And maybe it will, maybe it won't. So let's simplify the numerator. It looks like I can combine that 14 minus 12 to be plus a positive 2. So let me just erase that and write that. Okay, so nothing canceled, but that's okay. It's better to leave your denominator in these factored forms instead of all FOILed out. As we learned from simplifying rational expressions last week, that we always want to factor and leave it in that factored form. Okay, so that's actually my final answer since I can't factor the numerator any further and nothing's canceling out. So I'll leave it just like that. Now, I really, really want to stress that the reason I was able to do this in basically 3 steps is because of the smart work that I did. Now, if you just kind of blindly go through and say, I think I'm going to distribute here and let's see what happens. I think I'm going to do this. Let's see what happens. It might end up being like a way longer problem than you want. So for instance, like realizing that these x minus 9s canceled because you had them in all 3 terms, that was like super clutch because now you didn't have to distribute the x plus 9 every single time. It saved you a ton of work. So pause and really think about what you're doing. It's going to save you a lot of time. The other thing that was really helpful is we factored this right away, so it saved me from a ton of distributing. In fact, sometimes you can distribute so much that you have so many terms that you won't actually know or have the capability of factoring and you kind of get stuck. So factor what you can up front like we did and then cancel any terms you can the whole time as you go. So before I have you guys do this U-try, which is pretty simple, I'm going to do a guided U-try, and I'm going to do this one with you, our second to last one for today, really similar to the one we just did. The reason I'm going to make it guided is because I really want to make sure you understand how to do this type with trinomials. So I'm going to have you guys pause and do certain steps, but I'm going to be here to help walk you through it. So I first want you to just pause the video and think to yourself, what would be the first step I'd do in a problem like this? And if you get stuck, rewind like a minute or two and see what I did as step 1 in the problem we just did. So pause it and just let yourself think and see what would you do first if you saw this. Okay, so hopefully you thought of this or rewound and saw what I did on the last one. But since you have a trinomial, see if you can factor this first. That way you don't have to multiply a ton of things out. So let's do that. Factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Which ones can add to get me to -5? That would be 3 and 8. And I would do a -8 and a +3. And when you multiply these numbers, you get -24, so we're good. And when you add them, you get -5, so we're good. So let's rewrite that denominator as x minus 8 and x plus 3. And then I'll just rewrite my second fraction, not changing anything. That's going to be a huge time saver. So hopefully that was what you did as your first step. Okay, so after that, second step is let's get common denominators. So go ahead and on your own, I want you to write out what the common denominators would be and make sure that you've written the correct numerator and counterbalanced for whatever you multiplied in the denominator. Okay, so this is what it would look like with my common denominators. I just multiplied all these denominators together. And then in the numerator, the one with the 7, it was already over these two terms, so I just had to put it, I had to multiply an additional x minus 8. So that's where this came from. And then this part right here, these two, came from the fact that in this fraction with the 3, you just had the x minus 8. And so to get these other two, I had to add them in the numerator as well. So basically, whatever denominator they're over, make sure you multiply it by the other one. Okay, good. So from here, pause the video. Make sure you understand it so far, because we're not going to do another example like this, but this is going to be one that comes up quite a bit. Pause, make sure you understand every step I've done so far, and then think about what would be the next step we do right now. Okay, so hopefully you're good to go with what we've done so far, just making common denominators and compensating in the numerator by multiplying those additional factors. So the next step, and hopefully you got this, is that you would recognize there's an x minus 8 here, here, and here. So since it's in all three, you can cancel. Now if you had canceled it this one right here instead, that's no big deal. It's the exact same thing. As long as you're only canceling one of the x minus 8s, then you're good. So what would be left? Well, this term, since I canceled that, would just have a 7. And the other one would be 3 times x plus 3. And in the denominator, I would have x plus 3 parentheses x minus 8. I'm not going to FOIL that because, again, I purposely want it in factored form. Notice I cannot cancel this and this because it's not written in this term right here. So it's not in all three, so that would be incorrect to cancel the x plus 3's. Instead, what I can do is just go ahead and FOIL out, or distribute out, not really FOIL, but just distribute that 3 to both terms and just start combining some things. So that would be 3x plus 9, and the denominator still just staying the exact same, x plus 3 parentheses x minus 8. And lastly is just notice that the 9 and the 7 can be combined together to make 16. So I'm just going to erase all this and just rewrite that right there. So that was 3x plus 16 when I combined it together. So there's nothing else I can factor from the numerator, and the denominator I already factored. I canceled everything I possibly could, and so that is my final answer. Again, kind of the key things to make this easy is I factored this trinomial right off the bat. That was helpful. And I canceled these x minus 8s right off the bat. That was also really helpful. So that'll be a pattern hopefully you've picked up on by now and can do that on your own now. So I know that I heavily walked you guys through that, but I did feel like that was important because you're going to see this type a lot, and it's a really important type to be able to put together. So I'm going to go backwards now and have you guys do this one. It's easier because you'll notice there's only 2 terms in the denominator. And so go ahead and do this one start to finish on your own. And when you are ready to check it, hit play. All right, here's my first step, just getting common denominators. I wrote them out separate like I did in the first example just to show anyone who's still struggling on common denominators. This had an x minus 5, so I multiplied it by this additional x plus 1 to both top and bottom. The 4x one already had the x plus 1, so I multiplied it by x minus 5 right here in the denominator, so I need to do that as well in the numerator. Okay, so now that I have common denominators, I can put this together. So my denominator is just these two things multiplied together. My numerator, I'm going to go ahead and distribute while I'm at it. So that's 7x plus 7, and over here would be 4x squared minus 20x. Okay, and now I can combine anything together that are like terms. So I can put together this 7x and negative 20x and rewrite what I would have. And you know, while I'm at it, why don't we put it in standard form? So I have 4x squared, I'll just write out on the front end. And then that minus 13x, which you get by putting together the terms I circled, plus 7. And the denominator is still just the exact same thing, your x minus 5 times x plus 1. Now from here, I would look to see if I could factor the numerator. So I would think of factors of 7 that could add to get me to 13. But you already have 4x squared, not just x squared. So you would have to think about binomials like this and fill it in, or like this and fill them in with like a 1 and a 7 and see if you can get that to work. It actually doesn't, so then I know I can't factor any further. I just wanted to remind you of what that process looked like, and so I am done. And that's it for today, you guys. Have a wonderful day.